Okay, so how to write down electrons configuration of atoms based on Bohr's atomic model. There are three rules which govern the way we write down the electrons configuration, and we are going to learn how to apply those rules by working on the samples given. Okay, let's start with sodium. Okay, here as you can see, sodium has an atomic number of 11. Which means that sodium has 11 proton and also 11 electron. Okay, um, if we draw the structure, it will, look like this. Okay, at the center we can find nucleus. It has proton and neutron in it, and then electrons are distributed on these shells around the nucleus. And now we'll learn how to distribute all those electrons according to these three rules. Okay, let's start with rules number one. According to the rule, it says that each shell has its own maximum number of electron. Okay, the formula of the maximum amount of electron is 2n squared. Okay, by substituting the number of shell, we can find that the number or the maximum amount of electron in shell number 1 is 2, the maximum amount of electron in shell number 2 is 8, and then the maximum amount of electron in shell number 3 is 18, the maximum amount of electron in shell number 4 is 32. So if we have 11 electron, we need to distribute these 11 electrons, right? So first we place the electron in the first shell. Since the maximum amount of electron that we can, place in the first shell is 2, so we write down 2 here. Okay, next, we'll go to the second shell. The amount of electron that can be placed in the second shell is 8. We have 9 left, right? So since the maximum amount of electron that can be placed is only 8, we can write down 8 here. That means we have 1 electron left to be placed in the next shell. Hence, we write 1 here in the third shell. Okay, if we draw the structure, it will look like this. This is the first shell, right? We draw 2 electrons in the first shell. We use a dot to represent electrons, and then 8 electrons in the second shell. So we draw 8 electrons in the second shell, and then 1 electron in the third shell. So we draw 1 electron in the third shell. Okay, that's how you draw the atomic structure of sodium. Now we'll move on to calcium atoms, which has 20 electrons. Okay, we'll start with placing the electron in the first shell, which is 2, since the maximum amount of electron is 2, and then the second shell is 8. The third shell, well, the maximum amount is 18, but since we only have 10 electrons left, we cannot place 18, right? So how many electrons can we place in the third shell? Let's take a look at rule number 2 and 3. It says that the maximum amount of electron in the outer shell is 8. So we cannot write down 10 here, since the maximum amount of electron cannot be more than 8. Okay, now let's take a look at the third rule. It says that if the outer electron is more than 8 but doesn't reach the maximum number of the shell, then write the number according to the maximum electron of the previous shell. Well, the maximum amount of the previous shell is 8. Hence, we write 8 down here. Okay, so now we have 18 electrons distributed. We have only 2 left. We write 2 in the fourth shell. Okay, now we'll continue with rubidium. Rubidium has 37 electrons. Okay, we'll start with the first shell. There are 2 electrons placed here. The second shell 8 electron, the third shell is 18 electrons. So far we have 28. Therefore we have how many left? We have 9 left, right? Okay, we use the second and the third rule. Based on those two rules, we have to place 8 electron here because it cannot reach 18, but it is more than 8. So we have to write down 8 here. We have 1 electron left in the outer shell. Okay, now let's continue with xenon. Xenon has 54 electrons. Okay, we'll start with the first shell. There are 2. Second shell, 8 electron. Third shell, 18. We have 28 electrons so far. Okay, we have how many left? 26, right? We have 26 left of electron. The maximum amount of electron in the fourth shell is 32. It cannot reach 32. Hence, we have to write down the maximum amount of the previous shell, which is 18. Okay, so we write down 18 here. Therefore, we have 46 electron distributed. That means we have how many left? We have 8 left, right? So 8, we put it here in the outer shell. It is okay because the maximum outer electron is 8 and this is 8. Okay, now what about radon? You try it by yourself, okay?